Hi, this is Algebra 1, Lesson 74. We're going to talk about uniform motion problems of the form distance 1 plus distance 2 equals some number. And we're starting on page 391. Up to now, all of our uniform motion problems have had equal distances. So either both vehicles went the same distance, or someone went there and then they went back again. So they were traveling the same distance both times. So we have had the rate of 1 times time 1 equals rate 2 times time 2. The distances have been equal to each other. In this lesson, D1, distance 1 plus distance 2 is going to equal some number. So for example, if distance 1 plus distance 2 equals 352, the diagram of the problem could look like this. Either we have two vehicles or people or something that are going to start at the same point, and one of them is going to travel this way, one of them is going to travel this way, and D1 plus D2 is going to equal 352, which is the distance of both of them together. Or we're going to have two distances that are 352 miles apart, and D1, the first vehicle is going to start from this direction, the second vehicle is going to start from this direction, and they're going to meet in the middle. So then their sums will also equal 352. Okay? So either they're going to start at the middle and they're going to work their way apart, so they are 352 miles apart, or they're going to start at the ends and they're going to come together. And the total distance they traveled will be 352. So when we write this down, the rate 1 times time 1 still equals distance 1. So we're going to say rate 1 time 1 plus rate 2 time 2 equals 352. I have the hardest time not saying R2D2. R2T2. Alright, so here is our first example. A southbound bus left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. If the buses traveled at the same rate and were 352 kilometers apart at 2 p.m., find the rate of the buses. Okay? So, we see that the distance they've traveled is 352 kilometers. So if the distance of the northbound bus plus the distance of the southbound bus equals 352, then we know that the rate of the northbound bus times the time of the northbound bus plus the rate of the southbound bus times the time of the southbound bus equals 352. Right? Their rates are equal. So the rate of the northbound bus equals the rate of the southbound bus. The time of the southbound bus, which started at 9 o'clock and at the end, and we're stopping at 2 p.m., so that's 5 hours. So the time of the southbound bus is 5 hours. The northbound bus started 2 hours later, so it's only been traveling for 3 hours. Okay? Now we can substitute into the original. Because the rates are the same, we can drop the subscripts and we'll just call them R, because the rates are the same. And so instead of substituting RS into this, we're just going to call them both R. So we have rate times the time going north, which is 3, plus the rate times the time going south, which is 5, equals 352. So we have 8 times the rate equals 352. If we divide 8 from both sides, we have R equals 44 kilometers per hour. So the average average rate they were both traveling was 44 kilometers per hour. Okay, that's not so bad. Let's try another one. A train starts from Toledo at 11 a.m. and heads for Mackinac, 332 kilometers away. At the same time, a train leaves Mackinac and heads for Toledo at 65 kilometers per hour. If the trains meet at 1 p.m., what is the rate of the first train? Okay, since the distance between Toledo and Mackinac is 332 kilometers away, then that makes the total difference, the total sum of the distances that the two trains travel to meet each other, 332. So we can say that their total distances is 332 kilometers. So we have the rate of train 1 times the time of train 1 plus the rate of train 2 times the time of train 2 equals 332. Okay? We know that the rate of train 2 is 65 kilometers an hour. So rate of train 2 is 65. Okay? They both left at 11 a.m. and they're meeting at 1 p.m. So their time is the same and the time equals 2. Because the time is the same, we can drop the subscripts and just call these both t, which makes life much easier. Okay, so we're solving for the rate of the first train, so we can substitute these values into the top equation and solve for R1. So R1 times the time, which is 2, plus R2, which is 65, times t, which is 2, equals 332. So we have 2 times the rate of train 1 plus 130 equals 332. Subtract 130 from both sides. And 2 times rate 1 equals 202. So the rate of train 1 is going 101 kilometers per hour. Okay, let's try the next one. The ships were 400 miles apart at midnight and were headed directly towards each other. If they collided at 8 a.m., find the speed of both ships if one was going 20 miles per hour faster than the other one. Alright, so here's a happy problem. So the total distance the ships will travel is 400 miles. So assuming our ships are the Titanic and the Invincible, we have the rate of the Titanic times the time of the Titanic plus the rate of the Invincible times the time of the Invincible equals 400 miles. Okay. They both left, or we're starting to look at them at midnight, and they're going to collide at 8 a.m. So their time is going to be equal, and their time is going to equal 8. Okay? Their rates, the rate of one ship is 20 miles an hour faster than the other, and it doesn't say which, so we're just going to guess that the rate of the Titanic is 20 miles an hour faster than the rate of the Invincible. Okay? Now we can substitute these into the equations and find the rates. Okay? So we have the rate of the Titanic is 20 plus the rate of the Invincible, so we're going to substitute that into this RT. So we'll have 20 plus the rate of the Invincible times 8 plus the rate of the Invincible times 8 equals 400. So we have 160 plus 8 times the rate of the Invincible plus 8 times the rate of the Invincible equals 400. we have 160 plus 16 times rate times the invincible equals 400. Subtract 160 from both sides. We have 16 times the rate of the invincible equals 240 divided by 16. Rate of the invincible is 15 miles per hour. The rate of the Titanic was the rate of the invincible plus 20, so that's going to equal 35 miles per hour. Alright? And that is it for this lesson. Okay? Try your practice problems. Let me know if you have any questions. And that's it. Thank you very much.